Hi! So in this video, I'm gonna show you a really interesting application of linear algebra in the real world. So as a computer engineer, I write code. And what I'm about to show you now is actually one of my programming homeworks this semester, which involves image processing and linear algebra. So as we all know, an image is made up of pixels. So basically, an image is a matrix that contains pixels as its elements, and these pixels by themselves are arrays of RGB values that gives its unique color. So to make it more understandable, we can say that this matrix is an image, and each of this ABCD is its pixels that contain RGB values, red, green, and blue. Okay, so what I want to do now is, given this image, I want to create this output. As I just said, this image is basically just a matrix. So how can I rotate this image by its matrix? Interestingly, what we're going to use is a really simple concept that we learned in the beginning of the semester. This can be done simply by, drum roll, getting the transpose of the matrix. Let me show you. Okay, so what I did here is basically through each row of this matrix, I go through each column, and then I created a new matrix to store this, and then I have this first and this original one, and I calculated its transpose. So given this picture, I was able to create this, which is just the rotation of this, and this, the rotation of this, and this here, which is just a transpose, basically. A really simple concept that we usually take for granted, but actually creates great results. Moreover, given a picture, we can put filters on it by simply multiplying the matrix by a scalar. Yes, just a scalar. So, in order to get the grayscale representation of the matrix, we get the average value of all these colors. So we get the average of the red, we get the average of the green, we get the average of the blue, and that will give us a grayscale tone. And I simply multiplied it to every pixel in that image. So if you want some other color, if you want some other pixels, you can multiply this by some other scalar, or it can also be an array if you want a mix of different colors. You can experiment through it. Moreover, this is applying mask on the image, where the intensity value of each pixel under the mask is multiplied by the corresponding value in the mask that covers it. It basically follows this algorithm where for each pixel you get all the surrounding pixels around it, and then you multiply that pixel, that specific pixel, by this matrix. So it's just a simple matrix multiplication, because we might think like, well, studying matrix multiplication, we're like, where am I going to use this? Here is the example of where you can use matrix multiplication, or even scalar multiplication. Really simple results that have interesting and great implementations. So if you think of photo editing applications on your phone, even Instagram, the filters they have there, it's simply matrix multiplied to another matrix to create that. Or if you want to, from a picture, you want it to look something like a painting, all you have to do is matrix multiplication. Simple idea in linear algebra that can lead to really interesting results now. So that's what I have found really interesting in this homework, is that when it was first given to me, I was surprised on how linear algebra was useful in understanding the concepts and algorithms behind the implementation of this code. There's a lot more applications where we of linear algebra and image processing, just like what professor showed us in class using the SVD decomposition. I wasn't able to write code for it due to limited time, but then it's a really interesting one that I might consider doing it in summer over the break. So yeah, this is one example of a really interesting application using simple concepts only. Really easy to understand and to realize, but then it is used widely in the real world. So yeah, thanks.